Alright class, we're going to look at some more examples of solving exponential equations. So the main property that we're going to use in this case is to try to set the bases the same. Okay, the exponents don't need to be the same, but we want to make the bases the same. Sometimes we're able to do this, sometimes we're not. You have to look at the problem and discern if it's possible. So when we set the bases equal to each other, it's at that point we can set the exponents equal to each other and then solve for the variable that we're trying to solve for. So let's take a look at an example. So in example number 1, we have 5 to the x equals 25. So remember, we want to set the bases equal to each other. So we can change 25 to base 5. So we would have 5 to the x equals 5, and we want an equivalent number to represent the 25, so 5 squared. 5 squared is 25. So since the bases are now the same, we can then set the exponents equal to each other. This is a very simple example, very basic. X is equal to 2. Now if we plug that number back in to check, so check 2, we rewrite the problem, plugging in our answer in everywhere we see an x, and it's pretty obvious that it checks out. Okay, let's look at example number 2. So again, when solving, I tell you guys we always undo GEM-DOS. So we undo adding and subtracting first. So in this case, before we even attempt to set the bases the same, we're going to go ahead and undo addition. We didn't have to do anything like that up here. So we end up with 3 to the 2x power equals 9. Okay, now that we're down to 2 bases, they're not the same, but we have to ask ourselves, can we make them the same? Well, 9 can be rewritten as 3 squared. So over here, we're going to rewrite it. Like that. And now we can use this new property that we learned, where if the bases are the same, we can set the exponents equal to each other and solve for x. Okay, checking our answer, we rewrite the problem, plugging in our answer in everywhere we see an x. And then simplifying, we get 3 to the 2nd power, which is 9. And it checks out. Okay. Third example. Here we start off with these 2 bases being the same, but they're on the same side of the equal sign. So recall that when you multiply like bases, you can add the exponents together. So we can combine these down to 1 base, and adding the exponents together, we have x, this x, plus x plus 1 equals. And then on this side, I'm going to go ahead and get rid of my radical. So I'm going to change it from radical form to exponential form because we want an exponent on both sides. So we're going to have 3 to the 1/2 power. Okay. So now that my bases are the same, we can now set the exponents equal to each other. I could have combined that but I wanted everybody to see that I was adding the exponents together. So we're going to end up with, and I'm going to go ahead and combine those two right off the bat here. We got 2x plus 1 equals 1/2. And now we're going to solve. Undo adding and subtracting first. Okay, and then undo multiplying and dividing. So I'm going to undo the times 2 by multiplying by the reciprocal. And I'm going to do that because I have a fraction over here. It's much easier to multiply by a fraction than to divide by an integer. Okay, so we could plug this number back in and check our answer. If I have time, we'll come back and do that. I want to make sure I get through all these examples here. So, example 5. So in this case, we see we have 3 for a base on the right, so we're good over here. So is there a way we can make the 27 into base 3? And sure, 3 times 3 times 3. So we would have 1 over 3 cubed equals 3 to the negative x. Let me zoom in here a little bit. And now when you have the base in the denominator, we don't want it down there. We want both bases to be in the numerator. So we're going to need to bring that base up. And remember that when you move something from one side of a fraction to the other, the exponent changes its sign. So we're going to have 3. We're going to move this up to the numerator. So we're going to have 3 to the negative third equals 3 to the negative x. Just like when we want to get rid of a negative exponent, we move it to the other side of the fraction to make it positive. Well, here's an instance where we would want to make this positive exponent negative in order to move that base to the numerator. So now that my bases are the same, I can set my exponents equal to each other and then solve for x. And again, if I have time, we'll come back and check that answer. Number 6. So maybe you saw earlier in one of my problems, yes, in example number 3, I notice I skipped example 4. But in example number 3, you may remember that we changed this radical to an exponent, and that's what we're going to do here in number 6. Five, the power is 1, the root is 2, and we'll move that to the top to make the bases, both of them in the numerator. And now that our bases are the same, we know that x equals negative 1/2. Okay? All right. Example 7. So in this case, we have a base of 2. We have some multiplying going on, some subtraction. So before we can do this, use this property, we need to get the base and the exponent by itself. So we're going to undo GEMDOS. So we're going to undo subtraction first. Undo multiplying and dividing. Since it's an integer over here, I am just fine with dividing by 4. If this had been a fraction, I would have multiplied by a 4th. So rewriting my problem. Sorry. Here's what we end up with. All right, now that we have a base on both sides, we look at them and they're not the same. So is there any way that we could make them the same? Well, sure, we can change 4 to 2 squared. So rewriting the problem, getting a common base, setting the exponents equal to each other, and then solving for x. So we have x equals 1/3. All right, let's go move back up to example 4, the one that I skipped over. And what do you think we should do first? You're right. Good job. We need to change this radical to an exponent. So the power is 1, the root is 3. So we would have 4 to the 1/3 power. Next, we want to make the bases the same. So we can change 16 to base 4. So 16 is going to become 4 squared. That's going to be our 16. And our 16 is raised to the x power, so we're going to have the x power on that. Very, very important to keep that x on as the exponent, even when you have a new base with an exponent. Because you remember the property? When you have an exponent raised to an exponent, you multiply. Good. So we're going to have 4 to the 2x power. All right, bases are the same, so let's set the exponents equal to each other. Okay, now I could divide by 2 on both sides, but again, since I'm dealing with a fraction, I'm going to go ahead and multiply by the reciprocal of 2, which is 1/2 on both sides. And 1/3 times 1/2 is 1/6. 1 times 1, 3 times 2. Okay, well, we're 13 minutes into this video, so I think I will end it here, and I'll see you guys in class tomorrow.